Next section is 11.4, which is special factoring techniques. Note that 11.5 is essentially just a review section. It has no new content, so I will not be making a video for it. We do still have homework on it, which will allow you to sort of put together all of the techniques we have up to this point, but there's no new concepts for me to go over. So some of this is things that we've seen before. If you think back to our special products section in our last chapter, we had previously a difference of squares formula, exactly this one. We've seen it before. We know that x plus a times x minus a is x squared minus a squared. It's called the difference of squares formula, and it's really useful to us now, because we can use it in reverse. As soon as I see something like 4y squared minus 9, I need to be able to look at that and notice that both of these are squares. Note that 4y squared, that's 2 squared y squared, which, if you remember our rules of exponents, is 2y squared. So I have 2y squared minus 3 squared. So I have exactly what I have in this formula. My x is equal to 2y. My a is equal to 3. That means I don't have to use any of my factoring techniques from my last section, though I can. I can jump straight to the end. I know that that means I have x, which is 2y, plus a, which is 3, times x, which is 2y, minus a, which is 3. To make sure I'm okay, I'm going to multiply that out. 2y times 2y is 4y squared. Good so far. 2y times minus 3 is minus 6y. 2y times plus 3 is plus 6y. So those are canceling out. Plus negative 3 times positive 3, minus 9. 4y squared minus 9. That's exactly what I wanted to have. I'm good. So I was able to factor this polynomial immediately into this without having to mess around with AC or anything like that. That's convenient. Similarly, I can use my squares of a binomial sum and binomial difference formulas that I had before. I knew that x plus a is equal to x squared plus 2ax plus a squared. Let's say I have this polynomial, 9x squared plus 12x plus 4. I'm going to notice that both my constant term and my x squared coefficient are squares. And that means I might have something of this form. Let's look at what they're squares of. Again, I'm going to rewrite 9x squared as 3x squared. That's thinking back to our conversation about exponents. So I know that the x in this formula is 3x. And certainly 4 is 2 squared. So the a in this formula is 2. So I know that my middle term, if this formula applies, I will have 2 times a, which is 2, times x, which is 3x. 2 times 2 times 3x. Well, what's that? 2 times 2 is 4, times 3 is 12, 12x. That's exactly what I have. So I know that what I have is, in fact, of the form x squared plus 2ax plus a squared, where x is 3x, a is 2. So that means that what I have is x plus a squared. 3x plus 2 squared. I can check that. 3x plus 2 times 3x plus 2. Multiply my first terms, 9x squared. My outside terms, plus 6x. My inside terms, plus 6x. My last terms, plus 4. 9x squared plus 12x plus 4. Exactly what I wanted. So again, I was able to take this not simple polynomial and use my formula to see quickly that it's this nice simple thing. Can do the same thing with the square of a binomial difference formula. Again, this is a formula that we saw before. I have the same numbers here, just with a different sign here. Because notice that the only difference between these two formulas is whether I have a plus or a minus on that term, right? So as before, my x is that 3x, my a is 2. I need to check that that bears out on my middle term. But if I compute minus 2ax, I have minus 2 times 2 times 3x. That is minus 12x. So that does bear out on my middle term. I have this polynomial, which is of the form x squared minus 2ax plus a squared, where x is 3x and a is 2. So I know that what I have is 3x minus 2 squared. Again, I can multiply that out to be sure. I'm sure, though. You can check if you would like to. We talked about the difference of squares. So a good question to ask at that moment is, do we have a rule for a sum of squares? Let's think about this sum of squares. I have x squared plus 9. All my factoring formulas, I want something of the form ax squared plus bx plus c. So I'm going to rewrite this as x squared plus 0x plus 9. Now I have a b. My factoring techniques say I now want two numbers that multiply to 9 and add to 0. Should not be hard to determine that no such numbers exist, especially since they both have to be positive. Two positive numbers that multiply to 9 and add up to 0? No. In general, sum of squares is not factorable. So difference of squares is easy to factor. Sum of squares, as soon as you see it, you know you can't do anything with it. It's not factorable. Now those were all formulas that we've seen before, but we have two new ones. The sum of cubes and difference of cubes formulas are great because, unlike the other formulas, they actually allow us to factor a lot of things you would not otherwise be able to factor, right? All of our formulas are only for things up to x squared. So if I look at something of this form, I would normally assume it's got a cube in it. I can't factor it. But since these are both cubes, I actually can if I remember this formula. All of the formulas that we've discussed in this section are things that you should memorize. You should know these formulas. They are extremely useful. But especially the cubes ones, because those are the ones that you can't just easily determine on your own. So how do I use this? I can tell you that x cubed plus a squared is equal to x plus a times x squared minus ax plus a squared. I can tell you to memorize that, but it's useless if you don't know how to use it. So I need to look at this example and determine, I'm asserting that these things are both cubes, but we need to determine what they're the cubes of. So I can think to myself, what number do I cube and get 64? So what number to the third power is 64? Well, maybe I'll think 4. 4 cubed? Yeah, that's 64. So I know that 4x cubed, that's 64x cubed. I determined that 4 cubed was 64, and then I just used my rules of exponents to pull the cubed out to the outside. And I happen to know that 25 is 5 cubed. Knowing some small cubes, fairly useful, but you'll always have a calculator with you. On all of our exams, you can have a calculator. And always in life, now that we all carry smartphones, you always have a calculator. So, if you need to check, just ask it, what's 4 times 4 times 4, and you'll get 64. You can just feel around for these things. So 5x cubed, that's 125. Y cubed. So when I look at this formula, I know that that x is 4x, and I know that that a, I should have this is not an x, this should be a y. And I know that a is 5y. So then I can plug into this formula. I have x, that's 4x, plus a, I just said that was 5y, times, I'm going to have to do a line break here for space reasons, but it's all together. That's multiplication. X squared, I'll do 4x squared, so that's 4 squared x squared, 16x squared, minus a times x, that's 4x times 5x, which is 4x times 5y, which is 4 times 5, which is 20, xy, plus a squared, that's 5y squared, 5 squared y squared, 25 y squared. I can multiply those together, make sure I would get 64x cubed plus 125y cubed. I'm not gonna, but you can check and make sure that we're right. We are. I'm confident. And we can do exactly the same thing with the difference of cubes. We have a formula, x cubed minus a cubed is equal to x minus a times x squared plus ax plus a squared. So I will look at these numbers and try and figure out what they're the cubes of. Certainly I happen to know that 8 is 2 cubed. 27 is 3 cubed. So 27 x cubed y cubed is equal to 3xy cubed. So my x is 3xy, and my a is 2. I plug into my formula, x, 3xy, minus a, 2, times x squared. So 3xy squared, 3 squared x squared y squared, 9x squared y squared, plus a times x, 2 times 3xy, 6xy, plus a squared, which is just 2 squared, is 4, plus 4. So I have factored this difference of cubes as this. Again, you can multiply that out, make sure we're right, but we are. I'm confident. Okay? These two formulas allow us to factor lots of things that we would not otherwise be able to factor, so long as it is a sum or a difference of cubes. All of these formulas will come back several times during the semester, sometimes at really interesting moments. Okay? And you are on your own for 11.5, the review section.